Hi everyone, this is the demonstration for Lab10 multi-class classification with GDC data by Group 9. And first, here is our Git repository for this lab. And in the README file, there are some detailed description. And this is the Git repos on the local host. So first, we need to download the data from GDC website. After selecting these conditions, we download the manifest. And by using GDC client, we download the mRNA files. It takes time, so I will not repeat here. So in this folder, you can see all the mRNA files. And we can run in the Python code check to check that if we have already downloaded all the data. Download JSON from the website to get the case IDs for the files. And we also need to run the Python code request method to get the meta data for the files and corresponding cases. So now we have already got all the data we needed to do the multi-classification. And considering that in the files meta there are sample types, and in the case meta there are disease type and primary site, we first try to get all the type of this data. So by running the gap type Python code, we can see that there are totally 12 sample types and 30 disease type and 54 primary sites. By running general label matrix, we can get a matrix that summary all the catalogs for this data so that we can have a better observation. So in these files, we can see that there is a files ID, sample type, disease type, primary site, and case ID. So based on this information, we can give labels for the files. And there are totally 11,486 data. So now we need to give labels for this data. So we give label based on the rule that if a sample comes from tumor, we will look at its primary site to get the label based on its primary site. And otherwise, we will give the sample directly labeled 0. So totally we have 54 plus 1, that is 55 labels. So we can generate the mRNA matrix now. During the process here, we realized that some data, some labels only has one data, which makes it impossible to do the multi-classification. So we remove some sample labels here. and eventually we get our mRNA matrix. Here is the matrix for mRNA. Now we start running a predict multi-class to do machine learning for this data. The evaluation are shown in this figure, and we can see that SVS has the best performance.
Hi, so for here, we're going to visualize the features after feature selection with TSNE and PCA method. First, we're going to go to the lab directory. Then run the code for PCA. Here we go. We got the PCA plot. Then we are going to plot the TSNE. I mean, visualize the features using TSNE method. Meantime, I think I should explain the code while it is running. Here is the code for the previous plot. just some headers directory file, and then take some data from the matrix file. So the key is to take the y data and x data. And train them, and using the PCA function to plot that. Similarly, for TSNE, headers, the same data, and then instead of using PCA, we are going to use SNE and then plot the figure. Still waiting for the visualization being plotted by the TSNE method. Still waiting. Yeah, something happens now. The figure should come up soon. Here we go, the plot for the TSNE method. Then we are going to plot the evaluation matrix and ROC curve for the model. So for the evaluation matrix, I think it's already been plotted previously. So right now I'm going to plot the ROC curve for the model. Also run the code. v4.py. Meantime, let's go through the code. So what happening here is I printed something for debugging, so hope you don't mind. Here. Also, for the same data, we are going to take y data and x data here, and then train the data using the function called train test split. And a lot of printing. That means I'm really debugging. Well, I mean, I'm really debugging a lot. And then learn to predict a class against another using this function. And then to plot this ROC curve like this here. Thank you.